Hello everyone. So today I'm going to be talking about estimating a population proportion. So a point estimate is the value of a statistic that estimates the value of a parameter. The level of confidence, which is what we're more concerned about, represents the expected proportion of intervals that will contain the parameter if many different samples of size n are obtained. So what that means is, like, say our parameter or the population has a certain mean, right? Then if we take a sample, say of 25 people 100 times from that, our confidence tells us that 95% of those means are going to be within that certain range. And then 5% maybe, depending on the confidence interval. You could have a confidence of 90%, 95%, doesn't matter. And that will tell you how many of those samples are going to have a similar or close mean. So now, given this graph, we can do some math. We can get an equation for the upper bound and the lower bound. So the upper bound is equal to the population proportion plus error, okay? So this is our error that's okay. Past that, it's not okay anymore, right? So our confidence interval is based off an error value. And then our lower bound is the population parameter minus the error, okay? So this is a systems of equations, all right? So if you remember that from intermediate or college algebra, that's what we're dealing with here. We're not actually going to solve them. I'm just going to give you this equation. So the equations are P, or population proportion, is equal to the upper bound plus the lower bound divided by 2. Okay, so that's important. And then E is equal to the upper bound minus the lower bound divided by 2. So you can prove that to yourself later on. Another thing that's important about this section, and you should know all of this from chapter 8, is if we take this equation and we call the top of this E, right? So we have Z, or our Z-score equals E divided by the standard deviation of the population proportion. And we solve this for our error, then we can find our error easier. Okay, so E equals Z times the standard deviation of the population proportion. Now let's go ahead and plug in the equation for that, which is right here. So this is the equation we're going to be dealing with a lot. Z equals, E equals Z times the square root of the population proportion times 1 minus the population proportion, or Q, is what I like to call it, over N. So we're going to need this later on. And a lot of times when you're dealing with this, they have this little alpha over 2 here. Okay, so what that's coming from is, say we have a confidence of 98%. Okay, so that means if we look at our graph here, 98% of our data is going to be from here to here. So that's 98% of the data, right? So that means alpha, or our allowed error, is going to be out here, okay? Our margin of error, alpha. So 1 plus 1 is 2%, okay? So you know, if your confidence interval is 98%, that means you have a 2% margin of error. But you have to cut that in half, because we're going to end up needing the Z-score here or here. They are both the same. One's positive, one's negative. And that's where the z alpha over 2 comes from. So we have a 1% here, or 0.01, and a 1% here. And if you notice, all three of them have to add up to 100, and they do. So this is what you need to know for this section. Okay, so here's an example of this. Say we want a confidence level of 92%, all right? So from our graph, we want 92%, or 0.92, of our means to be our confidence level, right? So we know if this number is 92%, that means 4% of our data lies here, and 4% of our data lies here. If we plug our number, into this equation pretty much, we get 1 minus 8%, because 92% is our confidence interval, so that means alpha is 8. But we don't deal with the number 8 anyways. We deal with the 4%, because that is going to tell us the z-scores, right? So we have our margin of error is 8. But we want to find the z-score for 4%, or alpha over 2, okay? Z for 0.04. So what you have to do, and I'll post this in the video, is you take your normal table, right? And you look for 4% on there, okay? And then you find the z-score based on that. So you're kind of going backwards from what we usually do. And here, z-score for 4%, which is equivalent to z-score for 96%. Okay, these are the same number. We're going to take the absolute value of it anyways, because we just want the z-score. We don't care. We'll deal with the negative and positive thing later. All right, but it's 1.76. Okay, so here's our first example. Given an upper bound of 45 and a lower bound of 0.13. Remember, these are all pretty much percentages. With a population size of n equals 1400. A, find the population proportion. So remember, that is our mean. Okay, so we're finding the mean. And earlier I gave you that equation. All it is the upper bound plus the lower bound divided by 2. You could even call that the average, okay? So we have 0.13, or actually 0.45 if we're going in order here, plus 0.13 divided by 2. So that's 58 divided by 2, or 0.29, okay? So that is like, we can compare that to if a survey was yes or no. 29% of the people in this population would have said yes, okay? 0.29. And then we have our upper bound and lower bound. So our upper bound is 0.45. And our lower bound is 0.13. Now we also would like to know what the error is, okay? So our actual difference here. Now, we could tell right here, it's just 45 minus 29, or 0.45 minus 0.29. But let's just use the equation I gave you in the beginning. So we have E equals U minus L divided by 2. So 0.45 minus 0.13 divided by 2, which is 32 divided by 2 is 0.16. And we can verify that too. So this is going to be 16 up. And this is going to be 0.16 down. Right? And then we want to know the sample size. So the sample size is going to be given to us by this equation. Okay, so remember, this is just a proportion of the people that said yes divided by the total number of people. Now we have two of these numbers. We have the 0.29, so that's 0.29, and we have the population size. So we can find how many people are in this sample by multiplying 1400 over to the other side. So x equals 0.29 times 1400, so x equals 406 people that said yes in this survey. Okay, so another example. For a confidence interval of 95%, find the upper and lower bound of the sample of x equals 25 from a population of 125, where this is n. Okay, so right away we're given x and n, so you know you can find your population proportion p. That's just 25 divided by 125 is 0.2. Okay, so that's kind of a dead giveaway. Then we have our confidence interval 95%, which means our margin of error is the remaining. Okay, so alpha is 0.05 or 5%. Right? Because if we want a confidence of 95%, then we're going to have an error of 5%. Right? Now, with this, we can figure out the z value that we're going to be plugging into the z times standard deviation, which gives us the error. Okay? So we have z of alpha over 2. Okay, so that's the z value for 0.025, that's 2.5%. Because remember, on our normal curve, okay, badly drawn, but we have our 95% here. So 95%. And then this is going to be 2%, actually 2.5%. And this is going to be 2.5%. But we only need one of those z-scores, right? So we go to our table, we look for 0.025 and make it positive, okay? So our z-score is going to be 1.96. And then we go to this equation. Okay? So E equals Z, alpha over 2, times the standard deviation, which is P times 1 minus P divided by N. And we plug in our numbers, we get our answer. And then we can find the upper and lower bound based off that. Okay, so we have equals 1.96. Like I said, we'll deal with the plus and minus later. That's where the upper and lower bounds come in. The square root of our population proportion, which is 0.2, times the inverse of that, which is 0.8. Not exactly the inverse, but it's 1 minus that number. And then n is 125. So from there, we get an error of 0.07. Okay, pretty nice error because it's 7%. Then we can find our upper bound and our lower bound, given P. Okay, so U is P hat plus the error, and L is P hat minus the error. So we just have 0.2 plus 0.07 and 0.2 minus 0.07. So the upper bound is 0.27. So we have 0.2 here, 0.27 here, and 0.13 here because that is our lower bound. Okay, so example number 3. A survey asked 582 subjects if they were happy with their car insurance. 501 said yes. Find a 99% confidence interval for the population proportion that said yes. Okay, so right away, they give us a bunch of stuff. They give us the population, the proportion of them that said yes, and then we're finding a 99% confidence interval. Okay, so if we're finding an interval, and we know our proportion that said yes, which is our mean, then we need the error to add and subtract to that mean, and that'll give us that interval. Okay, so the error equation is E equals Z, alpha over 2, times the standard deviation of the population proportion, right? And then we have our own equation for this. So first, let's figure out the numbers that we need. We have P hat is 501 divided by 582, x over n. And then we know Z of alpha over 2. Okay, so first of all, alpha is 1%. 1% error, because right now we want a 99% confidence. So our 1% error cut in half is going to be 0.005. So you look for this on the table, or you type it into your calculator, the z-score for 0.005, right? So these numbers are 2.57 for the z-score, or 2.5 standard deviations up or down. And then we have 0.8608. When you're doing these problems, make sure you read the number of decimal places they want before you actually do the problem, because that'll tell you how many you have to carry throughout the problem. Okay? So our alpha gave us this 0.05, then you look it up on the table. Then we can plug in our numbers. Okay, so we have E equals Z, which is 2.57, times the standard deviation is, remember, the square root of our success, or people that said yes, percentage, 0.8608 times 1 minus that, divided by the population, which is 582. So we get E equals 0.0369. Okay, that's our error. And the error ranges based on this. Okay, so if we add the error to this, we get our upper, and we subtract the error from this, we get our lower bound. So, upper bound is 0.8608 plus the error, 0.0369. So that is 0.8977. And then our lower bound is 0.8608 minus the error, which is 0.8239. So let's make a statement about what we just found, okay? So we can say with confidence between, let's say 82% and 90% of people said they were happy with their car insurance. with a 99% confidence level. Alright, so before I left you, I just wanted to give you some hints on the homework because some of them can be tricky. Otherwise, I hope you're all well and don't have COVID-19, and have a good day.